Good morning. Thank you. So what we'll talk about here to begin with is just looking at some options in the multicast network. So the title for IPTV kind of thing is, it could almost be any kind of multicast, right? So the agenda that we will look into is first of all a look at the IPTV component, and then we'll go into a look of the last mile, kind of the access network, and then up from the edge to the core network for the multicast enable. And at the end of the presentation, I'll try to go into some discussion, some slides around how to achieve 50 millisecond convergence for PIM-enabled multicast networks. And we'll talk a little bit about that, and I'll show you some of the test and implementation that is done. So in the IPTV beast, there's a lot of different equipment. So as we all know, encoders and servers, set-top boxes, and a lot of other stuff inside that particular one. I'm not going to look at the overall picture of IPTV. I'm basically going to look at IPTV delivery from a network perspective. So basically going into, first of all, the IP edges, the access node, and then what I choose here on this particular slide to call the edge aggregation node as well. So that's kind of the area of the network that I'm going to focus on. So if you take a look first, kind of to set the scene, I want to talk about what is done in DSL forum with the TR101 view of the world in broadband networks, and how they suggest to do multicast delivery in the access network. So that's basically what is defined by the access node as and the IP edge, or as in TR101 where it's called the BNG, the broadband network gateway, right? So I'm going to take a quick peek at that and just show what different options is listed in TR101. So TR101 specifies two different models for the access network. It specifies a multi-edge network where there will be an IP edge, or BNG as it's also called, right, that will service all the internet unicast data traffic. So typically like PPP sessions coming in and being terminated on the IP edge, and multicast delivery down to the set-top boxes in an IPTV network will typically go over a second multicast enabled router, so like a dual edge setup. So that's one scenario that the TR101 is listing. It also lists another scenario where it's called like a single edge, and the functionality of the network is exactly the same, right? It's just a matter of whether two boxes or one box or whatever handles the same services. So in the single edge, basically internet data traffic, the unicast PPP termination or an IP session termination will be terminated on the IP edge that is also servicing the multicast delivery downstream, basically, right? So that's in essence like the difference between a multi-edge and a single edge topology in TR101. It's basically, do you split out services in a box-by-box case, or do you consolidate the services into a single box? So if you take a little bit closer look at the different components, so here I call it the broadband network gateway, just to be a little consistent with the TR101 naming. So I call it IP edge on the slide and broadband network gateway on the title, so it's just to confuse myself. So basically, the IP edge there is responsible in a multicast delivery here, right, in TR101. The IP edge is responsible for delivering the multicast replication on a per access node basis. So basically, it's not responsible for per subscriber or per household multicast replication, right? It's only responsible for a per access node replication. And one of the new functionalities in the multicast scenario that was introduced in TR101 was basically this notion of having an interface where you receive IGP joins on, but you do not service the multicast delivery out of that particular interface. So that's kind of the new introduction, I would say, that is of any value in TR101 that is a little bit, I won't say surprising, but the idea here is that if it's a dual edge or if it's a single edge, the IGP joins could come over the subscriber's PVP session, but we don't want to encapsulate the multicast stream going downstream into PVP. We want it being able to deliver that over an IPOE, so that they can have like a multicast service VLAN, and then individual PVP session per household, or individual VLANs per household. So that's more or less like what the IPX is responsible for, right? If you take a look at the access node, so the access node becomes responsible for the per residential gateway multicast replication, or per household replication, right? So basically, it's kind of, you can say, multi-states multicast, right, which is like naturally multicast networks, right? It fans out more and more the further down you go, and which basically gives you a great bandwidth utilization in the network, right? So the access node will service every single household. If a household comes in and joins a channel that is already present at the access node, it will only be delivered to that access node once, right? And then it will basically fan it out into multiple DSL ports, or whatever ports it is on that particular access node. So TR101 also specifies multiple snooping requirements for the access node. It has something that it calls transparent snooping, which basically means that any IGMP joins that come from the residential gateway to the access node should pass untouched basically through the access node, and also as such get up to the IPX. So if people wanted to, they could have a full subscriber view, a full household view of multicast delivery up on the IPX, even though he didn't do the actual multicast replication on per household, right? So that's one thing. It is also very beneficial in the sense when, if you want to do some rate adjustment to the household for the unicast traffic based on what multicast traffic is being delivered from the access node, that can also be accomplished with that transparent snooping. But that's only one of the snooping models that TR101 is suggesting, right? It also has what it called snooping with report suppression, so which is almost the same, or which is not, if it's not exactly the same as IGMP proxy, right? At least in my terminology, it's kind of the same, because what you do is you get in an IGMP join on the access node, and you only forward it up to the IPX if there is a need to do so. If you already have the stream, you don't forward it. So, and in the snooping with report suppression, they also say that you're allowed to, as an access node, you're allowed to rewrite that IGMP packet if you want to. You don't have to forward the original one. So, to me, it very much smells exactly like a proxy model.
Real quick question.
Yeah.
If you don't forward it, if the group is already joining, you don't forward the join up to the IP edge, the state's going to time out. So do you make it incremental state in the IP edge?
So if you don't forward it up, so basically what in the IGMP with report suppression or the proxy, the access node is responsible for, as soon as it joins once, to make sure that it doesn't stay timeout. But he won't forward new joins, basically. And then basically the next step that is defined in Tier 101 is the residential gateway, right? So the household. And the residential gateway basically in this particular setup is the brain of the home. So he becomes the IGMP proxy for the home. So if there's multiple set-top boxes behind the residential gateway, they will all be serviced from that particular residential gateway. So residential gateway only join a stream once, and if two set-top boxes watch the same channel, it will be replicated from the residential gateway. So basically, it gives you IPX will replicate per access node will replicate per residential gateway, and then residential gateway will replicate per set-top box inside the household. Right, so that's kind of the setup of the TR101 multicast delivery. One other interesting piece that was introduced in TR101 is that IGMP joins should be able to be serviced with an IP address of 0000. So basically, the residential gateway do not need to have an IP address allocated for it to join the different multicast streams. And then this can be done since the access node is directly connected to the residential gateway, right? So you don't need an IP address. You can just basically look at what port is this particular join coming in from. And if the packet is forwarded up from the access node to the IPX then will have to look at MAC address or something like that if you want to differentiate and find out what particular household is this particular coming from, right? But that's another part that was introduced there. So let's take a quick look here at 3 different options. So one option that is defined there is in the sense where you have the top line as a PoE session that is basically being set up, getting an IP address via IPTV. So now the residential gateway have an IP address associated with the PoP session, which will service all unicast and typically internet best effort kind of traffic. But at the same time, there is an IPoE encapsulation interface as well without an IP address on the residential gateway. And the only thing that is used for is basically receiving the multicast traffic that is being streamed downstream from the access node. So it basically means that in this particular setup, people can go out and introduce an IPTV network without changing any models, basically, right? They can start delivering multicast over IPoE encapsulated, but without having an IP DHCP network, so to say, because the IP address is associated with the PoP session for the internet traffic, and there's no IP address associated with the IP interface. Sorry, just back one step there. And this particular setup here is basically the setup where the residential gateway have to fork out the joins both on a PoP session as well as on the IPoE. So basically what the residential gateway will do in this scenario is it will send a join to any channels out both on the PoE session as well as on the IPoE encapsulated interface. So the access node will snoop on the IPoE, but it won't snoop on the PoE traffic. So option number 2 is basically where the residential gateway only send out the IGP join on the IPoE encapsulated interface. Again, there's a PoP session in play here. So the residential gateway have an IP address on the PoP session, which means they don't have to have one on the DHCP as well, because it's only using the IPoE encapsulated interface for receiving multicast traffic and communicating the IGP joins upstream. But since IGP joins in this particular setup is allowed to be communicated with 000, you don't need an IP address again there, right? So again, you don't need to have a DHCP enabled network for this particular thing to work. So in this particular thing, traffic will always, IGP joins only go on the IPoE to the access node, and then the access node will forward it to the IP edge, either in a transparent or in a snooping kind of the report suppression mode. And then finally, if you have networks where there's no PoE session for the internet traffic, right, then you have to have a DHCP enabled network or static IP addresses, as some people also do. But it basically means that now you have an IP address associated with the IPoE encapsulated interface, and everything works like honky-dory as we would expect, right? There's no surprises in that particular one. So that's more or less what is defined and talked about in the Tier 101 when it comes to multicast delivery. Yeah.
Did the standard consider using AMT and then just have the AMT session run over the PPoE session?
No, it did not look at that at all. No.
Didn't consider it, okay. Because the IP edge could be an AMT relay, and you could just have all multicast packets at that point be encapsulated in unicast and sent over the existing infrastructure.
Yeah, that would have been another, right? It did not take that into consideration at all. So if you look at the next step up in the network, if you try to take a quick look there from the IP edge and going up into the core. So this has nothing to do with Tier 101 per se, right? So this space is the IP space, right? And it's always like defined in IHF or other standard bodies, right? But nothing to do with DSL forum. So basically, in this particular scenario, there's many different ways to go in the design, right? So what do you do in an IPTV network? Do you go all IP and basically PIM enable your whole network, or do you go layer 2 transport for some part of the network for the multicast delivery, right? So there's a lot of different options to take into consideration. I'm not going to dive into all of the options here. So, but basically just some of the obvious discussions that typically in the core, whether you PIM enable that core or whether you do point-to-multipoint multicast delivery, right? So that's typically the discussion, and that's the one I'm going to focus on in this particular next slide here, right? So basically, from an edge access, if you look at different IP edge network designs, right, what we see out there is typically ring topology, a square topology, or kind of star topology. And I know that there are many flavors of these kind of topologies, right? But it's just to give you an idea that no matter what is being done in the edge, it would be doable in the next couple of slides to apply this multicast fast recovery for all these topologies if you wanted to, right? So the next couple of slides, I focused on the star topology, and I have one slide at the end of it as the square topology. There are some challenges in the ring topology. We can get into that later on if we kind of got time. Otherwise, if anyone is interested, we can take it offline. But this is basically what it is. So if you look at these different access networks, so if it's a carrier Ethernet-based aggregation network, there are definitely some challenges to make multicast fast recovery, right? Because how do you detect failure, and how do you make sure that you forward traffic in a carrier Ethernet-based aggregation network? It's typically spanning tree or rapid spanning tree kind of thing, right? But it's a shared one, so you have the whole issue with IGMP, designated routers and so on, who delivers the multicast and how do they communicate which one. So there's a lot of challenge in that particular one. There's challenge in the MPLS as well, and VPLS. Exactly the same kind of challenges, right? Because it is kind of a one broadcast domain in that essence. So what I will try to take a look at is much more on the actual PIM functionality of this. So if we look at IGP Fast Convergence, so there's been a couple of very good presentations earlier in other NANOC meetings, right, that have focused on fast convergence for IGP protocols, right? And basically all routers out there today have implemented more or less functionalities that will allow IGP to do fast convergence. So it basically means that IGP protocol is implementing an event-driven model, right? So if something happens, the SPF calculation can take effect immediately. But if there's a lot of turbulence in the network, they kind of back off and go into a timer mode and so on. So there's also some routers out there that have optimized PIM a little bit so that in case of PIM will receive joins on RPF interfaces, typically, like according to the standards, you just drop it, right, and wait for a retransmit. Some routers have optimized that a little bit, so they keep the original PIM join a little bit and see if there's an IGP convergence that is in progress. And if so, the RPF interface might change, and you might want to service that particular join that comes in. So there's different options there to even speed up the convergence. So if we take a look at this, what PIM typically do, right, when it relies on IGP convergence, right, there's no surprise in this particular one. I did the example basically based on what I call static PIM, which basically means that pull down the multicast traffic to the IP edge ahead of time before you get an IGMP join coming in. So it basically will say, this is actually something that is deployed in many networks, right, where they make sure that the multicast stream is present on the IP edge ahead of time, and then when a household want to subscribe to one of the channels, it's being serviced right out of the IP edge instead of go all the way up to the video servers. So send out a PIM static join and basically make sure that the multicast traffic is being pulled down to the IP edge devices. Then when an IGMP join comes in, we basically start delivering that particular traffic to the access node and to the household. In case of a failure in this particular network, what happens is now a link failure between the IP edge number 2 and edge aggregation. The multicast traffic that is being streamed to the household will stop, right? Because there's no more multicast traffic going to the IP edge. It's waiting for the IGP to convert from the IP edge. As soon as that do, it will send out a new PIM join up to the other edge aggregation router and basically get the stream from that one and start servicing the access node and the household again in that particular one. So there is going to be a blip in the multicast delivery here for the duration of time for the IGP convergence, basically, and the new PIM join and the multicast delivery to be streamed again. So no big surprises here, right? With all the optimization that is done in IGP for the different routers, what we've seen in network is that this can actually be optimized down to the hundreds of milliseconds. So you can actually get pretty good convergence performance in multicast just by relying surely on IGP convergence and normal multicast behavior. But basically driven from some big IPTV middleware server requirements, right? there's a requirement to get down to the 50 milliseconds convergence time for multicast to guarantee that you do not get like picture freeze and blue screen on your TV and so on. So with that in mind, more work has been done here, right? And one of them is MPLS point-to-multipoint delivery, right? One of the big advantages of that in the multicast is that you can benefit immediately from MPLS fast reroute to get down to a 50 millisecond delivery time or recovery time in case of a failure, right? But if you want to go all IP and all PIM, basically, this can also be done, right? So basically, if we do something that we call PIM Dual Join, and it's basically just lesson learned from multicast high availability financial networks out there today, where the receiver will pull down a multicast stream from 2 different sources, and the receiver will decide itself which one to use, basically, right? So it's just this particular scenario that is being taken up into the IPH, and the IPH, which is the last IP-aware replication point before the multicast receiver, right? He now, on behalf of the clients, pull down the multicast stream from 2 different sources, and as such, if a network failure occurs further up in the network, it can become a local decision for that IPH what stream to service the access node and the household with. So that's kind of the idea of the PIM Dual Join. So it also takes one more change for the PIM Dual Join to work in all scenarios, right? It can rely on a local failure and a kind of a light out failure situation, but a lot of networks have layer 1 transmission equipment in between, so you need some kind of protocol as a keep alive protocol to make sure to detect when link failures or when node failures basically happens, right? Typically in BFD, the individual IGP routing protocols will register as clients to BFD. So what we have done here is also we allowed PIM to register for BFD. So basically we'll get BFD notification if there is a link failure or if there's any kind of failure to the BFD keep alive. And as such can take action on its own without waiting for the IGP convergence and the RIP basically to do route convergence. So if you take a look at this and how it will look with the dual joins, so basically now in this star topology here, IPH number 2 will send out 2 joins, 1 on each link, so basically we'll join the stream from the 2 different edge aggregation routers. And you basically fill up all the links that is in that particular network then with the multicast. So every single IPH here will receive the stream twice, once from each node on the aggregation one. When an IGP join comes in from the access node, the IPH can then decide which one of these multicast streams that I'm receiving is my primary multicast stream, and as such basically join and add that particular access node to the OIF list for the primary multicast stream there. Now in case of a failure, of a link failure, it basically becomes a local decision for the IPH to switch the stream from edge aggregation router number 1 down to the stream received from edge aggregation router number 2, right? So basically switching the whole OIF list from a primary RPF interface down to a secondary RPF interface. So if we take that thinking and kind of do a quick comparison with the MPLS point-to-multipoint and see what is the pros and what's the cons of PIM dual join compared to an MPLS point-to-multipoint delivery. So PIM has dynamic leaf addition and removal, right? So in the access network, if you don't want to pull down all the streams to the IPH, which you probably don't want as soon as the IPTV networks kind of grows and you have a lot of channels there, high definition channels or standard definition channels, right? You don't want to fill up the bandwidth all the time. So you might want to get into a dynamic behavior where when a household wants to watch a channel, at that point in time you pull it down to the IPH and only have maybe the most popular channels being delivered to the IPH all the time, right? So that's, PIM is a great addition for that because it's allow you to do the dynamic leaf addition and removal, which point-to-multipoint at this time MPLS don't allow you to do, right? It's the static nail up through that point-to-multipoint LSP. PIM don't have a tree optimization, which point-to-multipoint do have, right? So in access network, this is probably not the most important part because very seldom would I expect people in the last jump of the access network to actually make any traffic engineering for the multicast delivery. But that's something that PIM won't be able to help you with if you wanted to. But the fast reroute, both of them will be able to give you 50 millisecond fast reroute capabilities, right? Because both of them are basically local decisions. So if we take a quick look here at this particular slide here. So if we now look, instead of a star topology, which I went through before, if look at a square topology, where like IP edges would be connected together. So if you look at this and you want to do point-to-multipoint LSP protection, you have to set up a lot of backup LSPs as well to be able to protect this. Where in the PIM Dual Join, all you have to do is on the IP edges basically configure that this is a dual join, and you have to send out joins in 2 directions instead of only on the IPF interface, right? So the provisioning of this is a lot easier to give you 50 milliseconds protection than it is for the MPLS. And another thing is that with the MPLS, in some unfortunate situation, you actually can fill up your links in failure situation with double the amount of traffic. So if you reroute some of the LSPs over already existing LSP, right, you will be able to have 2 LSPs carrying the same multicast traffic in a failure situation on a link, which you will never have in the PIM Dual Join. You will always only have the same amount of traffic on the links, whether it's a failure or a non-failure situation. And then just at the last slide here, just want to show a little some of the tests that has been done in a network. So basically, this network that we did the testing one was being designed in a star topology. So an IP edge had connectivity up to 2 different edge aggregation routers, and they pulled down in this test pulled down the multicast traffic to the IP edge ahead of time. So before any IGP joint came in, the multicast traffic was already present at the IP edge. So, and then we were running BFD between the IP edge and aggregation router 1 and 2 basically, with a multiplier of 3 and a transmit and receive interval of 10 milliseconds. So basically, for BFD to see a link failure or a node failure, that will take you a little bit more than 30 milliseconds right there to detect the failure. So what we basically saw there was that the IBH sends a primary S-G PIM join to aggregation 1 and a secondary S-G PIM join to aggregation 2. And then we introduced a link failure as well as a node failure. And first in the static join, when the traffic was being pulled down, and in the recovery, if we just recover based on light out, which means no BFD kind of thing, right, the recovery time is a little bit more than 11 milliseconds. If you rely on the BFD to tell you when the link is down instead of light out kind of thing, you add those 30-something milliseconds to it, and it takes a little bit longer. So, but 48 milliseconds was pretty consistent, below 50 milliseconds for the recovery time there. And it basically, those numbers replicate itself whether the traffic was being pulled down to the IPH ahead of time with a static join, or whether they were dynamically joined via IGMP-v2 or IGMP-v3 kind of joins there. So pretty consistent that, and this test was done with 100 different channels in the MFIP, so basically 100 TV stations, so to say, to be streamed to the set-top box and being failed over here. That was the last slide for me, just to give you an idea of the PIM Dual Join there. Thanks.
Do you have any questions? Okay, I think the next speaker is Eric Osterwall, so if you can come up here real quick.
Quick question.
Take the questions.
Davidson, University of Washington. In your conversation on TR101, it sounded like the ANs only build a multicast table for all of their downstreams. Is there any way to resolve if you have an AN that's supporting multiple IP edges upstream, i.e. where you have a competitive AN that has the Lex, local IP edge, and potentially others, and how it would resolve separate multicast tables for each?
Inside the access node, if it
Yeah.
sets up.
So in the access node has the physical connectivity from the DSL end users, and
Right.
then concentrates it up to the IP edge.
Right.
It is, what happens if there are multiple IP edges for that access node? Aggregation node, sorry.
Where different IP edges are servicing different multicast ports, basically, so to
Yes.
say, right?
Does it just have one view that it then consolidates down for all of the downstream customers, or does the standard support virtualization of that?
It actually do not. So the standard talks about one-to-one correlation between access node and IP edges.
Okay.
But I don't think that there would be anything, it would be an access node implementation kind of thing, right? But
Yeah.
the functionality would be able to work in that sense as well if it could divide it up into different partitions. So they are in the standards talk about different partitions in an access node, but it do not specify specifically whether it should have a different multicast view in each of these partitions.
Okay.
Okay.
Potentially where there's a competitive situation there, you might want that, or an isolation issue that you have there.
Yeah.
Say
yeah.
you have a corporate downstream customer on an AN, and they're potentially reusing IP multicast groups that you have upstream on your IP edge for like the local provider.
Yeah, true. Yeah.
So, okay.
Thanks.